So here is our answer from example 2 in factored form. And we notice that our first x cubed can be gotten by multiplying x times x times x. But the key thing that I want you to notice is that your last term is a 12. And your last ones in each of these multiply to get 12. That's going to be key, because when you're asked to factor something and no hints are given, like in this question, in question 2, they gave you some examples. They said try x plus 1, and then you find out that it's a factor. Try x minus 3, and then you find out that it's a factor. But if you're not given any examples to try, you've got to find one that works. And this last number is your hint. Because if it's going to work, it's not going to be x plus 7. Because 7 doesn't multiply nicely to get 12. It could be x plus 6. Because 6 does multiply by 2 to get 12. It could be x plus 12. So we have to look at that last number and say, what are all the ways that we can multiply to get 12? In other words, what are all the factors of 12? 1 and negative 1, 2 and negative 2, 3 and negative 3, 4 and negative 4, 6 and negative 6, 12 and negative 12. And those would be all of the possibilities that you would have to try with the remainder theorem or with synthetic division until you find one that works. And once you find one that works, say you found that x minus 4 worked, then you could use synthetic division to break it down simpler and factor it all away. But it's going to take some time to find that one that works. Now, this idea is listed on the bottom of page 18. Thank you. And it's called the factor property. And the factor property says if something is a factor, then that number has to divide the last term or the constant term in our polynomial as well. So when we go to our example 3 here, now with that idea in place, this is an easy cubic to factor. This is an easy cubic to factor because the last number is a small number. What are the factors of 2? 1 and 2, or negative 1 and negative 2. So we're going to have to try one of those values to see if we can get it to be a factor. Use our factor theorem or a remainder theorem. So we've got 1 and negative 1, 2 and negative 2. What value would you like to try first? Negative 2. Okay? Now, as far as trying values go, I'm glad you said negative 2, because it would be one that I wouldn't necessarily choose first because the math is harder. Does that make sense? That you're going to have to do more math with a 2 than you would with a 1 or a negative 1? But that's not necessarily a bad thing, because maybe negative 2, we could either try using the remainder theorem and plug in is that a plus 2 at the end? So if we try negative 2, what do we get? Well, 3 times negative 8 is negative 24. This is going to be minus 16 plus 10 plus 2. We get negative 28. That tells us that x plus 2 is not a factor. So you have a little bit of luck as well. You could choose all the wrong ones to guess first and only get one that works at the very end. You could also be lucky and on your very first try get one that works. So we tried negative 2, it didn't work. So again, this is a really good example for picking negative 2, because not only does it show that it's a little bit harder to do the math because the 2 is bigger than a 1, and it didn't work, so we have to do another one. What would you like to try next? Positive 1. I like doing positive 1 first because it's the easiest one to do the mental math. Yes?
But like right now, since we know that there's a 2 at the end, and we know that the 2 doesn't work, couldn't we
Like we only have 3 options.
know that the other 2, that the negative 2 will have to work?
We don't know that the other 3 will work. It's true that you could have up to 3 factors, but just like there's some quadratic functions that are not factorable,
Doesn't 2 have to be one of them because there's a 2 there, and
Yeah.
you have the other 2 cannot?
not necessarily, because I could have
Oh, yeah, the 3.
3x plus 2 as a factor, or 3x minus 2 as a factor with that 3. So again, it doesn't necessarily work. We'll see if it does in this case, but we're going to try 1 next. 1 is nice because the mental math is really easy when you plug in 1. 3 minus 4 minus 5 plus 2. What does that equal to? Oh, negative 4. So that was a really good one to try because the mental math was easy. But again, we failed. Found another one that's not a factor. Which one do you want to try next? We've tried positive 1, now let's put in negative 1. Okay. Plugging in negative 1, this will make this negative 3 minus 4 plus 5 plus 2. It works! Hooray! Whew. It would be disastrous if none of them worked. This means, what's a factor? This means x plus 1 is a factor. And now we can use synthetic division and write our division statement to see what happens. So 3, negative 4, negative 5, 2. Those were already written in the correct order. And we're starting with an x cubed, and we have 4 numbers, so we don't have to put in a 0 for anything. We are going to divide by x plus 1. So what number would we write here? We'd have to write minus 1. Again, this is one place where you just have to pay attention because we're switching the signs a lot. We switch the signs with the remainder theorem. Then when we get our factor, we switch it back. But then when we do synthetic division, we switch it again. You could also have done the first 3 steps with synthetic division as well. And if you had done this originally with synthetic division, right, you wouldn't have to do this as a second step, right? 3, negative 3, negative 7, 7, positive 2, negative 2, 0. Perfect. So we got a remainder of 0. And if we write our division statement, we now know that our original polynomial, which was 3x cubed minus 4x squared minus 5x plus 2, is equal to x plus 1 multiplied by 3x squared minus 7x plus 2. This is our polynomial, divisor, quotient. We write plus remainder, but our remainder is 0, so there's nothing to write there. It said factor fully, so now we have to say, can we factor that 3x squared minus 7x plus 2? Since that's a quadratic, we can go to our skills with factoring quadratics. What has to be first in here, if it's factorable? Has to be a 3x and an x. Can you see the way that you can use your last one so that your outside and inside makes 7? I think you're going to have to watch to see how loud that picked up. 1 here and 2 here. That makes 2. Our outside is 6. Our inside is 1. That does make 7 if they're both negative. Quickly multiply it out to check, and yes, it does work. So this does tell us that if you would have plugged in 2, it would have worked, because x minus 2 is a factor. And that is factored completely. So the questions that I'd like you to try in this order, do 5, then 11, then 9, and finally end with 10b.